Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, paper 2, variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1 part A says table 1.1 list some SI quantities. Complete the table by indicating with a tick which rows are SI base quantities. So first of all, we need to understand there are 7 SI base quantities and 7 SI base units. First of all, time is SI base quantity and its unit is second. Length is SI base quantity and its SI unit is meter. Mass is SI base quantity and its SI unit is kilogram. Current is SI base quantity and its unit is ampere. Temperature is SI base quantity and its unit SI unit. SI unit is Kelvin. Amount of substance is SI base quantity and its unit is mole. Luminous intensity is SI base quantity and its unit is candela, CT. So these 7 SI base quantities and 7 SI base units you need to understand. So if you look at given table, current, this is SI base quantity, energy is derived quantity, force is also derived quantity, and mass is SI base quantity. So this is simply you have to take current and mass. Part B says use the definition of power to determine its SI base units. So power, simply hint is given to you, use the definition of power, and power is equal to work done over time taken, means rate of doing work. So simply we can say work done over time taken. So this is how you can write down, and work is equal to Ft. So this is force time displacement in direction of force divided by time taken, and F we can write on F is equal to ma. So this is times d divided by time. Now simply we need to write on the units. Unit of mass is kg, unit of acceleration is meter per second square, and unit of distance is meter, and unit of time is second. We can simplify this one. We can say this is kg, and here we have meter square and s to the power of minus 3. So this is SI base unit. So we can write on this is kg meter square s to the power of minus 3. So these are SI base units of power. Part C says a light meter is used to measure the intensity of light in a classroom. Daylight is incident normally on the sensor of the meter. Normally, it means that this one is the area and the light is incident like this. So the angle between them is 90 degrees. The sensor has an area of 2.2 centimeters square. The reading on the meter is 950 watts per square meter. Calculate the power of the daylight incident on the sensor. So simply we need to understand for this one, intensity is equal to power over area. We need to find power, so simply power will be equal to intensity times area. Intensity times area. And value of intensity is given to us, that is 950 watts per square meter. So this is value of intensity, and area is given to us in centimeter square. Centimeter square. So we need to understand 1 centimeter, this is equal to 10 to minus 2 meters, and 1 centimeter square, this will be equal to square of this. It means this will be equal to 10 to minus 4 meter square. So simply we have to replace now centimeter square with 10 to minus 4 meters square, and this is, of course, this is multiplied. Now if we solve this one, we will get in this case 0.21 watts. So this is the final answer, and given data is this has 2SF, this also has 2SF, so the final answer should have 2SF. So this is our final answer. Question 2 part A says define acceleration. Acceleration simply is equal to delta V by delta T. So simply this is rate of change of velocity. So we can say acceleration is rate of change of velocity. So this is how you can define acceleration. Part B says an Olympic diver stands on a platform above a pool of water as shown in figure 2.1. When the diver is on the platform, its center of gravity is a vertical height of 9.0 meters above the surface of the water. The diver jumps from the platform with a velocity of 5.9 meters per second at an angle of 60 degrees to the horizontal. Air resistance is negligible. When the diver hits the surface of the water, his center of gravity is a vertical height of 1.2 meters above the surface of the water. Calculate the speed of the diver at the instant when he hits the surface of the water. So for this one, first thing we need to understand the center of gravity of the diver. The change in position of center of gravity of the diver is the difference between, we can simply say delta H, this is equal to 9.0 meters minus 1.2 meters. So the decrease in height of center of gravity is equal to 7.8. We can also define a reference point. So at this position we can define GPE, gravitational potential energy, this is equal to 0. So now simply we can use conservation of mechanical energy. So we can say kinetic energy initial plus GPE initial. GP initial, this has to be equal to kinetic energy final plus GPE final. So GPE final. So we have GPE final, this is equal to 0, and we can write down kinetic energy final, this will be equal to kinetic energy initial plus GPE initial minus GPE final. GP final, but GP final is equal to 0 because we have defined this is reference level and GPE at this point is equal to 0. So in order to calculate kinetic energy, mean the speed of the diver, the final speed, we can say 1/2 mv square. This has to be equal to 1/2 mu square plus mg delta h, or we can say initial height. So mass we can cancel, it is not depending on the mass. So we can write down v square. If we multiply both sides by 2, we can say v square will be equal to u square plus 2g times delta h. So value of u we have, that is given to us 5.9. So simply you can plug in here. So this is 5.9 square plus we have 2, and value of g is 9.81 and the height is 7.8. So this is the height. And now if we solve this one, we will get value of v, that will be equal to 14 meters per second. So this is value of v. So this is how you can calculate. So conservation of energy for this question is very helpful. You can also use kinematics concepts, but conservation of mechanical energy is the best tool for this question. I hope this question helped. If you have any questions about this one, if any point is still not clear after this explanation, please leave your questions in comments and I will try to answer as soon as possible. Part C says the diver in B enters the water and decelerates. Describe and explain the variation of the viscous drag force acting on the diver in the water as he moves downwards. In the question, the first thing you need to understand, it is given to you, it decelerates, mean the speed decreases. So simply we can say speed go down. Now we need to understand the drag force, or simply you can say drag, this is equal to 1/2 rho a v square. This formula you don't need for A level, but simply you need to understand drag force is proportional to v square. So if v go down, it means drag force will go down. So this is what you need to understand. So how we can write down the answer? For the answer of this question, simply you can say as diver moves down, his speed, so you can say his, or there you can say his speed decreases, so drag force decreases. If you write on these 2 points, you will get 2 marks. Second part says the diver has a volume of 7.5 times 10 to minus 2 meter cube. The density of the water is 1.0 times 10 to 30 kgs per cubic meter. Show that the upthrust acting on the diver when he is underwater is 740 newtons when he is fully submerged inside water. So this is very important, when he is fully submerged in water. So how we can calculate upthrust? So simply we can say upthrust in this case will be equal to mass of the fluid displaced times g, means simply is equal to weight of fluid displaced. And weight of fluid displaced means the mass we can write down. This will be equal to density of the fluid times volume of the fluid displaced times g. Density of water we have, that is equal to 1.0 times 10 to 3 kgs per cubic meter, and volume of fluid displaced. In this case, this diver is fully inside water, so volume of fluid displaced is equal to volume of person, volume of diver. And volume of diver we have, that is equal to 7.5 times 10 to minus 2 times value of g, that is equal to 9.81. Now if we solve this one, we will get our final answer 740 newtons. So this is final answer. This has 2 SF, this also has 2 SF, so the final answer should have 2 SF. So this is our final answer. Third part says at a particular instant when the diver is underwater, his horizontal velocity is 0. The viscous drag force acting on him at this instant is 950 vertically upwards. The diver has mass of 78 kgs. Determine the magnitude and direction of the acceleration of the diver. So first thing to do for this question is sketch the free body diagram. When the diver is moving downward, the force acting on the diver in downward direction is mg, and there is a force on diver due to the fluid, that is the upthrust, and upthrust is acting in upward direction, and also there is a drag force on the diver, so we can say this one is drag force, and diver is falling down, so this is direction of velocity of diver. So in this case we can write down F net, this has to be equal to drag force plus upthrust minus mg. So this is F net. We need to find out value of acceleration, so we can say F net will be equal to ma, and this will be equal to d plus u minus mg. We need to find out value of a, so this will be equal to simply d plus u minus mg divided by m. So value of d we have, that is equal to 925, then we have value of upthrust, that is equal to 740, and minus we have mg. M is 78, g is 9.81, and this is divided by 78. So if we solve this one, we will get 12 meters per second per second. And this is value of acceleration. As the sensor is positive, it means acceleration is in upward direction, because we have taken upward positive, and the final answer is also positive. It means net force is in upward direction. So simply we can say value of acceleration is 12 meters per second, and direction is vertically upwards. So we can say direction is vertically upwards. So this is how you can answer. Nice question. So you need to understand how to use F is equal to ma. F is equal to ma is a very important formula in mechanics, especially when you're solving questions based on forces and kinematics concept. I hope this video was helpful, and if this video was helpful, and also other videos on channel, if those videos are also helping you, please like and subscribe, because your encouragement is very important. With your encouragement, I'll be able to spare more time, and I'll be making more and more videos for you to help for your exam preparation. And also, if you're looking for extra resources, please join Patreon. On Patreon, you will see a lot of exam focused resources, not only for physics but also for other subjects. That's all for today's video, and I'll be uploading solution of remaining questions as soon as possible. And also, if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, paper 2, variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 3 says a thin metal wire X of diameter 1.2 times 10 to minus 3 meters is used to suspend a model planet as shown in figure 3.1. The variation with strain of the stress for wire X is shown in figure 3.2. For part A, the strain in X is 5.4 times 10 to minus 3. Use figure 3.2 to calculate the force exerted on the wire by the model planet. So for this question, we have value of strain of this wire and value of stress we can find from the graph. So simply we can draw this line so we can find out the value of stress. So this is value of strain and this is 5.4 times 10 to minus 3. So this is value of strain and we can read value of stress from here and this is equal to 0.72 times 10 to 9. So we have value of stress and stress is equal to F divided by A. We need to find out value of force. So force simply will be equal to stress time cross-sectional area, and value of stress we have that is equal to 0.72 times 10 to 9, and cross-sectional area of the wire simply will be equal to pi by 4 d square, pi by 4 d square, and value of diameter we have that is equal to 1.2 times 10 to minus 3 square. And now if we solve this one, we will get in this case 810 newtons. So this is the force acting on this wire. This is the tension in the wire. So this is how we can calculate. You can also calculate this question by calculating the gradient. We can take one point here or any other point you can also take. So gradient in this case, gradient will be equal to Young modulus because gradient is equal to stress over strain. So we can find out value of sigma, we can find out value of stress. So this will be equal to gradient times strain. So here we have gradient times strain, and then we can write down this one. So sigma is F over A and this will be equal to gradient times strain. So the force, if we multiply both sides by A, so we have to multiply by cross-sectional area here. So this is how you can calculate also value of force using this method by calculating gradient. But this is straightforward. We have value of strain, mean the strain in this wire, the value is here. At this value of strain, we have value of stress, and then simply we can use this formula and we can find out value of force. Second part says the elastic potential energy of X is 0.31 joules. Calculate the original length of the wire before the model planet was attached. Means simply we need to find out value of L naught, means the original length of the wire. When we attach planet, the length of wire will increase. So the question is simply asking us find the original length of the wire. So we can do this one in a little bit different way. So first of all, simply you can imagine we have this wire and there is no planet attached with the wire, and the length of this wire is L naught. Question is asking us to find out this value of L naught. And then we attach with this wire this planet, and this length, let's say this one is L1. So extension in this case will be equal to L1 minus L naught. So these are some important points you need to understand before you answer this question, so you can visualize this question, what is happening. I'm quite confident some student, they will be confused with this one before the model planet is attached. So they will be confused with this one. So you need to understand what exactly is given to you for this question and what you need to calculate. This is a way to develop your understanding of physics. Physics is not something imaginary. It's deal with real problems in everyday life. So we have to visualize this one. So how we can answer this question? So simply, first of all, you can see elastic potential energy is given to us. The elastic potential energy stored in this wire is given to us. So simply we can say elastic potential energy, this is equal to 1 by 2F times X. So we need to find in this case value of X. If we have value of this means delta L, we can find out value of L naught. So simply we can say X in this case will be equal to 2 times EP divided by F. So we have value of EP, that is equal to 0.31, and this is divided by a value of force we have just calculated in the first part. And if we solve this one, we will get value of X, that is 7.7 times 10 to minus 4. So this is value of X, and this is in meters. Now we understand that strain is equal to X over L. X over L, and this L is the original length. So we can say in this case L will be equal to X divided by epsilon strain. So we have value of X, that is 7.7 times 10 to minus 4 meters, and value of strain we have calculated in the last part. Actually that was given to us in the question, and the value was 5.4 times 10 to minus 3. So if we solve this one, we will get value of L, and this is L naught, original length. So we will get 0.14 meters. So this is value of L naught. I hope this makes sense to you how to approach this kind of problem. So this is how we can answer. Part B says wire X is replaced by a new wire Y with the same original length and diameter but double the Young modulus of X. Wire Y also obeys Hooke's law. On figure 3.2, draw a line representing the variation with strain of the stress for Y. So first of all, we need to understand what is gradient of this graph. So simply we can say gradient is representing stress over strain, and this is the Young's modulus, and this is Young's modulus means this is capital E. And for X we can say this is EX, and for EY means the Young modulus of wire Y, this has to be equal to 2 times of Young modulus of wire X. It also means that the gradient has to be equal to 2 times, means the graph has to be steeper. So how we can make the graph steeper? So gradient can be steeper. There are 2 ways we can do. So here we have, this is delta Y, this one is delta X. We no need to worry about the second point, so because this is passing through the origin, that's the reason we have written this is sigma over E, because this one is 0. So delta Y by delta X. One thing we can make this double, delta Y for the same value of X, we can have value of Y double, means for the same strain, if the stress is double, it means Young's modulus is double. For same value of strain, if stress value is double, it means Young modulus is double. So this is one way. And the second way is for the same value of stress, if strain is half, it means that gradient is double and Young modulus is also double. So we can write on here delta X. If this become half for the same value of stress, same stress. So let me write down here. it means that if same stress, value of stress is same, but strain is half. Strain is half. It means Young's modulus is double. So E is double. So we can say E double. So this is the main concept you need to understand. So E is double, and vice versa is also true. We can keep same strain and we can get double value of stress. So Young modulus again will be double. So these are the points you need to understand. Now if we can take any point, but this point is quite easy point. At this point you can see we have value of strain and we have this value of stress. And for the wire Y, if we keep value of stress same, means we keep this value same, so strain has to be half. So here we have value of strain is 6 and here it has to be half, mean it has to be 3. So we have 2, so this is 2.2, 2.4, 2.6, 2.8 and this is 3. So this is value of strain. Now simply we need to sketch the graph passing through that point. So passing through this point. So this is how you can sketch the line. So that's all what you need to do. I hope this question makes sense. If you have any questions, please leave your questions in comments. So Young modulus, let me explain you a little bit more about that. Young's modulus. So if we have same value of strain, for example, and stress is double, it means that Young's modulus is double. Same strain but double stress, it means Young modulus is double. And also this is possible, means the Young's modulus, this is sigma over epsilon. If we have same value of stress but strain in the wire is half, mean the change in length divided by the original length, that ratio is half, it means that Young's modulus is also double. And this is what we have done for this question. You can also do this one. This line will be the same. Question 4 says a nucleus P undergoes alpha decay to form nucleus Q. For part A, complete the equation for this decay. So it is given to us this is alpha decay. So the charge on alpha decay is +2. So we can write on 2 here. Then mass number is 4 because it has 2 protons and 2 neutrons. So this is nucleon number. Now we can find out the mass number of Q. So we have 215. So simply you can say 215. This one has to be equal to the mass number of Q plus 4. So it means this one has to be 211. So here we can write down this is 211. So here we have 84. So this is 84. This one has to be equal to the charge of Q plus, means the number of protons in Q, plus we have 2. So this one has to be 82. So simply we can say this one is 82, means Q has 82 protons. For part B1, we need to state the principle of conservation of momentum. Principle of conservation of momentum simply tells us total momentum before collision has to be equal to total momentum after collision for any isolated system. So this is simply how you need to state. And in our answer we can write down, so this is our answer. So in the answer you can simply say the total momentum of a system of bodies remains constant for an isolated system. So this is very important one. You have to say for an isolated system, otherwise you will not get 2 marks. Second part says before the decay nucleus P has a speed of 3.2 times 10 to 5 meters per second. After the decay nucleus Q is stationary. Calculate the speed of the alpha particle after the decay. So simply we have to use conservation of momentum. According to conservation of momentum, momentum before decay, the vector quantity, momentum before decay has to be equal to sum of momentum after decay, vector sum of momenta after decay. So this has to be the vector sum. Direction is very important. So simply momentum before, we have momentum of P, this has to be equal to momentum of Q plus momentum of alpha particle. Momentum of P we can find out the mass of P, so it has mass 215 U, and the speed of this one is given to us, that is 3.2 times 10 to 5 meters per second. So this one is the speed, and momentum of q is equal to 0 because this one is stationary, plus we have momentum of alpha particle. Mass of alpha particle is 4u times, we need to find the speed actually, so speed we need to find out, so this is v. So v we have to find, so simply we can say v will be equal to 215 u atomic mass unit times 0.2 times 10 to 5, and this will be divided by 4u. So this u will be cancelled with this, so if we simplify we will get value of v, that will be equal to 1.7 times 10 to 7 meters per second, means alpha particle will be moving at very high speed after the decay, so it has a lot of kinetic energy. So this question is quite straightforward one, simply you need to use conservation of momentum and you can find out the value of v for alpha particle. I hope this question makes sense and these two questions are clear to you. If you have any questions, please leave your questions in comments, and also if this video was helpful, please like and subscribe because your encouragement is very important. And if you're looking for extra resources, you can visit Patreon, you can join Patreon. On Patreon you will find a lot of resources for your exams. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 2, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 5 part A says, by reference to direction of propagation of energy state, what is meant by a transverse wave? So first of all, imagine that transverse wave is moving to the right. So this is direction of propagation of wave and this is also direction of propagation of energy. Now we can imagine medium particle here. So how this medium particle will move? This medium particle simply will move up and down. So this is direction of vibrations of medium particle. So this is medium particle. An angle between these two is 90 degrees. So simply we can say direction of vibration of medium particles are perpendicular to direction of propagation of wave or direction of propagation of energy. And for longitudinal waves, if wave is moving to the right, so this is direction of propagation of energy, so the medium particles, they will move forward and backward, and this wave is longitudinal wave. So this is representing longitudinal wave. So simply we can say this is representing longitudinal wave. So angle in this case is, they are parallel to each other. So simply you can say direction of vibrations of particles are parallel to wave direction. So this is how we can define longitudinal wave and transverse waves. Now let me show you the answer, how you can write down your answer. In your answer you can mention these points. You have to mention vibrations of the particles, you have to say perpendicular to direction of propagation of energy. So you will get 1 mark. Part B says a space telescope is designed to detect electromagnetic radiation with wavelengths in the range 12 micrometer to 28 micrometers. State the region of the electromagnetic spectrum. So simply you need to understand this range. For infrared, for example, so this is very important range. Infrared, they have wavelength between 10 to minus 4 to 10 to minus 6 meters, about this range. So you can see here we have micrometers, so because this is in meters, so this is micrometer. So it simply means that this is infrared. So simply you can say this is infrared. Part C says a detector on another space telescope detects an electromagnetic wave. The signal from the detector is transmitted to Earth and displayed on an oscilloscope as shown in figure 5.1. The frequency of the signal displayed on the oscilloscope is equal to the frequency of the detected electromagnetic wave. The time base setting on the oscilloscope is 5.0 times 10 to minus 15 seconds per centimeter. It means 1 centimeter is representing 5.0 times 10 to minus 15 seconds. Calculate the wavelength of the detected electromagnetic wave. So we need to calculate wavelength. So first thing we need to understand, in this case we are talking about EM wave. So very important one. EM wave means electromagnetic wave, and all electromagnetic waves, they travel at speed of light in vacuum and also very close to speed of light in air. So simply from here we can say the speed of all electromagnetic waves is 3.0 times 10 to 8 meters per second in vacuum or in air. So we need to calculate lambda. So we understand V is equal to F times lambda. So F times lambda, or we can say this is lambda over time. So from here we can say lambda will be equal to V times T, means time taken, V times T. Time taken, this time taken, very important one now. This time taken has to be the time period, because we are talking about one cycle, distance traveled by the wave in one cycle. So this time has to be time period. So simply we can say this is C times T, and this T is the time period. So if we have value of time period now, we can find out value of lambda, and value of C is 3.0 times 10 to 8 meters per second. So we just need value of time period. So how we can find value of time period? At this point we can take, it's more convenient, and we can take this point here. Actually this point, and it has to be this point here, somewhere here, this point you can see. You can take this point, you can take this point, or you can take this point, or you can take this point. So this is representing one complete cycle. So if I take this one, so this is easy to see. So let me draw this wave so you can see. This is representing one complete cycle. So this is one complete cycle. So how many small square we have? We have 1, we have 2, 3, 4, 5, and 6. So we have 6 small square, and one small square, we can say one small square in this case. So we can say one small square. One small square is 1 centimeter. So we can say one small square in this case is 5.0 times 10 to minus 15 seconds. So one small square is representing this. How many small square we have? 6. So the time period will be equal to 6 times 5.0 times 10 to minus 15 seconds. So you have to be careful with this unit. This is second. Now if we multiply this one, we will get over final answer. So in this case, final answer will be equal to 9.0 times 10 to minus 6 meters. So this is the wavelength. So this is also, you can see this is infrared because it is in micro. So this is our final answer. We can also write down here. So this is 9.0 times 10 to minus 6. As given data has 2 SF, so our final answer also should have 2 SF. Question 6 part A says coherent visible light of a single frequency is incident on a double slit. This produces a pattern of bright and dark interference fringes on a screen as illustrated in figure 6.1. There are 7 bright fringes. For part 1, explain how the pattern of bright and dark interference fringes is formed. Mean how these bright and dark fringes are formed. In order to answer this question, first thing we need to understand waves at this point, they are in phase. So we can simply say waves here, they are in phase. Now, first of all, we will look at the bright fringe, how this bright fringe is formed. This bright fringe is formed if the waves at this point on the screen, means at this point on the screen, if they are again in phase, so we will see a super wave, super crest like this. So this is due to constructive interference, and when the waves they meet on the screen, if they are in phase, they will form bright fringes. So this is when they are in phase. So simply we can say bright fringes are formed when the waves are in phase. And now if you look at dark fringes, I'll be just looking at this fringe. Dark fringe is formed when the waves, they reach the screen, means they reach this point, but they are anti-phase 180 degree. If the phase difference between them is 180 degrees, they will cancel each other, so we will see no light. So this is when they are anti-phase on the screen, so we can say anti-phase on the screen. So these are the points you need to understand to answer this question. Anti-phase also means that angle between them, phase difference, is 180 degrees, and in phase means that phase difference between the waves when they meet on the screen is equal to 0 degree. On the screen when they meet, if the phase difference is 0 degrees, it means constructive interference, and we will see bright fringe. And if the phase difference is 180 degrees, it means that is destructive interference, and on the screen we will see dark fringe, means no light. So you can see the beauty of that. Light can cancel. So it doesn't mean that if you have light always you will get something bright. So light can also cancel light. Something different from our everyday observations and from our everyday way of thinking. Means the normal way of thinking, not thinking as a physicist. So this is something very important one. Now let me show you the answer, how you can write down the answer. In the answer you can mention these points. You can simply say light diffracts at the two slits. Here light will diffract. So this is telling you the light will diffract here. Light from each slit superposes at the screen, means the waves from the slit, they will meet at the screen. If the phase difference is 0 degrees, we will see a bright fringe, and if the phase difference is 180 degrees, we will see a dark fringe. So this is how you can answer. It's a nice question. You need to understand how bright and dark fringes are formed, because this is a typical question in the exam. Second part says the distance between the centers of bright fringe X and bright fringe Y in the pattern is 10.2 millimeters. The slit spacing is 1.2 millimeters. The distance from the slits to the screen is 3.1 meters. Calculate the wavelength of the light incident on the slits. This is a typical question, but little bit tricky one. So how we can answer? In order to answer this question, simply we need to understand that AX, this is equal to lambda times capital T. And we need to find lambda. So lambda simply will be equal to AX divided by capital D. So we need to understand what is A. A is slit separation. Slit separation means that the distance between centers of slits. So simply we can say A is distance between centers of slits. Centers of slits. Center to center distance. So you can see here. So this is over value of A. We also call this is slit spacing. So this is slit spacing. So you need to understand these terms. Very important. Slit spacing. What is X? X is fringe spacing. Fringe spacing. But this is not complete answer. Fringe spacing, often confusing this one. So we need to understand this one a little bit in detail. What is meant by fringe spacing? So this is the distance between centers of, we can say distance between centers of two consecutive bright fringes. Consecutive. If you got this point, you will not make mistake. Distance between centers, so I'm writing here between centers of two consecutive bright fringes. So this is how you need to understand two bright fringes. But what is this distance? This is not X. This distance is not X. And this distance between slit and screen, we call this is capital T. So here we have value of A, that is 1.2 millimeters. So this is 1.2 millimeters. But value of X, we need to find out. Value of D we have, that is 3.1 meters. So you have to be careful with units. Now the question is how we can find x. So we need to look at this one. So you see we have bright fringe here, we have another bright fringe here. So we have 1 here, then we have 2, then we have this one 3, this one we have 4, this one we have 5, and this one we have 6. So this is 1, and here I can say this is 2, this one is 3, this one is 4, this one is 5, this is 6. It means this distance, we can say this distance d, let's say this is equal to 6x. But we need to find out x, so x will be equal to d divided by 6. So it means 12.2 millimeters. This has to be divided by 6. So this is what you need to understand. Now let me use arrow here to make it more clear to you. So this is one arrow, you can see. So this is 1x, this is 2x, this one is 3x, and here we have 4x, and here we have 5x. So here we have 6x, and this is equal to d. So it simply means that we need to write down x is equal to 10.2 times 10 to minus 3 divided by 6. Now if we solve this one, we will get lambda is equal to 6.6 times 10 to minus 7 meters. So this is value of lambda. Our answer should be up to 2SF, because the given data you can see it as 2SF. This one has 3SF. This one has 2SF. So in the final answer, you have to use the least number of SF in given data. Answer. So we can simply say answer. Number of SF are simply, let me write on here, number of SF in answer should be equal to least number of SF in given data. So this is the rule we follow, but you can use one more that is also acceptable. Given data or one more, we can use or one more. So this is how we need to answer. Question says the light is replaced by different visible light with a shorter wavelength. State how the new fringe separation will compare to the original fringe separation. So we need to understand we are using the same double slit, and this distance we are also keeping the same. So if we change lambda, how this fringe separation will change? So simply we can write down x, this is equal to lambda times capital D divided by A. We are keeping A same, we are keeping D same. So if lambda decrease, it means x will decrease. It means that fringes will be closer than before. So the fringe separation will decrease and fringes will be closer to each other. So this is simply we need to write down. We can say new fringe separation will be smaller. So we can say new fringe separation will be smaller, or you can say fringes will be closer. New fringe separation will be smaller than before, will be smaller than before. So this is how we can answer. Part B says a stationary wave is formed on a stretched string AB as shown in figure 6.2. P, Q and R are points on the string. For part 1 on figure 6.2, draw a cross to show the position of a node. So the best way to answer this one, first of all, we can complete the waveform of the stationary wave. So this is how you can complete it. It will look like this. Not very good looking, but at least you can get the idea. So this is how it will look like. Now if you look at this point is the node. So this point is node, means particle at this point has zero displacement, and particle at this point also will have zero displacement. So simply you can label this point x, or you can label this point x, even you can label this one x. So any point if you label, that is the node. So these are nodes. So if you want to write n here, you can write down. You can also write down here. So this is how you need to answer part 1. For the second part, we need to state the phase difference between P and Q. And you can see P and Q, they are between two consecutive nodes. So all particles, they have the same phase, means they have zero phase difference. So they have the same phase. at any given time they will be moving in the same direction, so they have zero phase difference, or we can say they are in phase. So between this, all the particles between these two nodes, they are in phase, and also particles here, they are also in phase, but these particles, they are moving up. Let's say this particle is here, so particle in this loop at this point will be moving up, particle here it will be moving up, and particle here will be moving up. And you can see particle here, for example, here they will be moving up. If we have particle here, this will be moving up. If we have particle here, this will be moving up. So the main point is, all the particles between two consecutive nodes, they have zero phase difference. So simply we can write on here zero phase difference. State the phase difference between P and R, mean this point and this point, and the phase difference between them is 180 degrees. Means when this particle is here at the lowest point, this particle will be at the highest point, and vice versa is also true. They will be moving like this, like this. So these are some very important points you need to understand about stationary waves. These are basic points, so you have to be very clear. And also you need to understand this particle, for example, and this particle, they do not have the same amplitude. The amplitude is different. All the particles means in this loop, they have different amplitude. So let me write on here, they have different amplitude, but they are in phase. So they have different amplitudes, but in phase, So these are the points you need to understand between here and here. Then same is true between these two nodes, same is true between these two nodes. So this one is true for each loop. So we can say for any loop, you can say for any loop, this is true for all. And that's all for this video. We will just stop this video here. We left only two questions, and those questions are very short questions. One is about electricity, one is about radioactivity, and I'll be uploading those two questions later by today. And if this video was helpful, please like and subscribe, because your encouragement is very important. And also, if you're looking for extra resources, you can check Patreon. And if you have any questions, please leave your questions in comments, and I will try to answer as soon as possible. And if possible, please share with your friends, so your friends can also get benefit from these videos. And also request them to like and subscribe. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 2, Variant 2. In today's lesson, our main focus will be on electricity and atomic physics. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these exam questions. Let's study together. Let's improve together. Part B says a cell of electromotive force 1.8 volts and internal resistance small r is connected in parallel with a resistor of resistance 6.0 ohms and a filament lamp as shown in figure 7.1. The switch S is open, the ammeter reading is 0.25 amps. Determine the internal resistance of the cell. So first of all, we need to understand it is given to us the switch is open. So it means that we are just talking about this part of the circuit. So first of all, we can draw this line. So you can see we are just talking about this part of the circuit. And according to Kirchhoff's second law, sum of EMFs in any closed loop has to be equal to sum of TDs in any closed loop. So this is the main concept, in any closed loop. So in this case, we have EMF that is equal to 1.8 volts. and we have current I times capital R. We have PD across this one. We can also draw voltmeter here, so we can say this is voltmeter 1, so we can say this is V1, and the reading on across this one, let's say here we have V2, but actually you cannot connect inside, but just for understanding we are saying PD across this one is V2. So V2 will be equal to I times small r. So we need to find out value of small r, so we can say small r, this one will be equal to 1.8 minus I times r, and this will be divided by I. So that's all. Now simply plug in values and you will get the final answer. So here we have 1.8 minus value of current, means current passing through this resistor, and this resistor is the same, and value of current is 0.25. Why current is the same? Because current coming from this side of the battery, it will pass through this one, and also it will pass through this. So current is the same because they are connected in series, and value of current is 0.25 amps, and value of this resistor, this is 6 ohms divided by 0.25. So if we solve this one, we will get 1.2 ohm. So this is value of internal resistance. So this is how you can answer, and this question is very common in many past papers you will see. So you need to understand that EMF is equal to I times capital R plus I times small r. If we have this circuit, all components, they are connected in series. So this resistor is connected in series with this. So this is the main idea, and this question is very common in past papers. Part C says at time t1 switch S in figure 7.1 is closed. Figure 7.2 shows the variation with time t of the ammeter reading capital I. State whether the EMF of the cell after T1 is greater than, less than, or the same as it was before T1. We need to understand EMF is property of the cell, and that depends on the chemical reaction taking place inside the cell. So it does not depend on external components. So it means that EMF remains same. So simply we can say EMF remains same because that is property of the cell, and that depends on chemical reaction. So we can say EMF remain same. It does not depend on external component, does not depend on external resistance. Second part says by considering the effect of the lamp on the total resistance of the circuit, explain the variation of the ammeter reading shown in figure 7.2. So this is our figure 7.2. So this is figure 7.2, and it is given to us. You can also take this one as a hint, considering the effect of the lamp on the total resistance of the circuit. Explain the variation of the ammeter reading shown in figure 7.2. Mean how this ammeter reading is changing. You can see here until this point this current is constant. So what does it mean? It means that resistance is constant. So simply we need to understand this formula. EMF is equal to I times R total. So we can say this is R total, and this is the total current. Initially we can see resistance is constant, means current is constant. So it means that if this value is constant, it means this is also constant because this is constant value. So this is one point we can write down. At time t1 you can see this current increases. So what does it mean? Let me rewrite this one. So here we have I, and here we have R total, mean total resistance in the circuit. This value is constant. So if I increase, it means that resistance decreases. So this is the second point we can write down, and after that we can see this current is decreasing. So current is decreasing. So we can rewrite here EMF is equal to I times R total. So if I is decreasing, this quantity is constant, so it means R is increasing. But we need to understand resistance of this resistor is constant. When we close the switch, it means that resistance of the lamp is increasing with time. So this resistance is increasing with time because this resistance is constant. This is a fixed resistor. So that's all what we need to understand for this question and to answer this question. I hope this makes sense to you. Now let me show you the answer. In your answer you can write down these points only. First of all, you can say before T1, when current is constant, total resistance is constant, as you can see in this part, before T1. And after T1, at T1, when current increases, the total resistance decreases due to decrease of external resistance. When we close this switch, total resistance decrease because this component is connected in parallel. So this is what is shown here. We have discussed this point here. After T1, temperature of lamp increases, so the resistance of lamp increases. So as resistance of the lamp increase, it means current is decreasing. Current is decreasing, so it means resistance of the lamp is increasing because this resistance is fixed. After T1, resistance of lamp increase, very important one, you have to mention this one. Resistance of lamp increases, not only the total resistance increases. So you have to say this resistance is fixed. As total resistance increases, it means that resistance of the lamp increases, and resistance of the lamp increases with temperature, and resistance of the lamp also increases with PD. So when potential difference across lamp increase, it means more electrical energy will be converted into thermal energy that will increase the temperature of the lamp, and as temperature of the lamp increases, it means resistance of the lamp will increase. This is very straightforward question and also a common question, but they have just asked you in a little bit different way, but it's a very nice question. So if once it is not clear, look at this question again and try to understand this question. This is very nice question and also a typical type of question maybe you will see in your coming exam. So then you can say total resistance increases, so current in the ammeter decreases. So if you write down these points, you will get 3 marks. So this is how we need to answer. Question 8, part A says, state the name of the class of fundamental particles that contains a neutrino. So we need to understand neutrinos, they belong to lepton family. So simply we can say they belong to leptons family, lepton. So this is how we can answer. All neutrino, they belong to lepton family. For example, we have electron neutrino, muon neutrino, tau neutrino. They belong to lepton family because they are not in the nucleus and they do not experience strong nuclear force because they are not in the nucleus. Part B says a hadron P has a charge of plus 1 E. E is the elementary charge. Hadron P is composed of a down antiquark and only one other quark. So we have hadron P, so it is given to us. This consists of one down antiquark and the charge on this one is plus 1e, and there is another quark is here, so we need to write down possible flavor for the other quark. So the charge on this one is 1 over 3e. So this is the charge on down antiquark. Because the charge on down quark, this is minus 1 over 3e. So this is first thing we need to understand. Now the charge on this one has to be equal to plus 2 by 3e. So the total charge will be equal to 1e. So this one, this quark, this can be up quark, this can be top quark, and this also can be charm quark. So you can simply write down here, you can write down up quark, you can also write down top quark, you can also write down charm quark. So you can write down C or you can write down charm directly. So you can write down charm quark. So this is how you can answer. For the second part, we need to state what type of hadron is. So we need to understand hadron they can be classified into baryons. So we can classify them into baryons and into mesons. Baryons and mesons. Baryons, they consist of three quarks. Quarks are antiquarks, means they consist of three particles. And mesons, they consist of quark and antiquark. They consist of only two particles. So they consist of quark and antiquark. As in this case, we have only two quarks. It means that this belongs to mesons family. Mesons. So this is meson. Part C says nucleus Q undergoes radioactive decay to form nucleus R, emitting an antineutrino and another particle X as shown in the decay equation. State what particle is represented by X. So you need to understand, it is given to us antineutrino is emitted. Antineutrino. Actually, this is electron antineutrino. As this one is electron antineutrino, so this is antiparticle. So this one has to be particle, means this one has to be electron. So this one has to be electron, so we can write down this one has to be electron to conserve lepton number. So if this one is, if this neutrino, let's say if this one is antineutrino, so I will be writing here, if this is antiparticle, if this is antiparticle, this one has to be particle, and vice versa is also true. If this is particle, if this one is particle, so if this is neutrino, this one has to be antiparticle. So this is the main concept you need to understand, because these two particles, one has to be particle, one has to be antiparticle to conserve lepton number. So the main concept is, this is what you need to understand. So this is, so this combination is possible and this combination is also possible. So this is main idea you need to understand. Now in this case, if this is -1, let's say atomic number of this one is Z, mean it has Z number of protons, and mass number is A. So this one should have Z plus 1 and this one should have A. So we can also write on 0 here. Neutrino, they have no charge and also no mass number. So this is 0. Now question is asking us, say what particle is represented by X. So this particle, simply we can say this is electron. So this particle is electron, because in this case electron antineutrino is emitted, so this has to be particle because this is antiparticle. So simply you can write down electron. Compare the nucleon numbers of Q and R. Nucleon number. So this is representing the nucleon number A here. So this is also A here. It means they have the equal, or we can say they have the same nucleon number. Same or equal, you can say. Compare the charges of Q and R. Charge on this one is Z and charge on this one is Z plus 1. Means charge on this nucleus is Z plus 1. So it means R has greater charge. So we can say R has greater amount of charge. Greater amount of charge than Q. So this is how you need to answer. And I hope this question makes sense to you. And that's all for this paper and also for this video. I hope this video was helpful. If this video was helpful, please like and subscribe, because your encouragement is very important. If your teacher spare 1 hour, 2 hours to make a nice video for you, so your teacher also deserve your like and subscribe. So please like and subscribe, and also if you have any questions, you can leave your questions in comments and I will try to answer as soon as possible. If you're looking for extra resources, you can check Patreon. On Patreon, you will see a lot of resources, not only for physics but for other subjects as well. See you in next video.